Okay, so setting up for fourth axis, a couple of considerations. How do we want to manage the work offsets? First of all, the other thing is that I drew this up without really thinking about the position of the rotary, but in most vertical machining centers, a rotary that is along the x-axis with a rotation. I built this hub to kind of remind me where that rotation is, and typically that would be on the right, right? Because you're going to set up the rotary table. The connection for the cables, the brush or brushless cable, has to snake its way up and over and back around the machine to the cabinet, and then the connections are on the back on the right side. So um, for convenience, you're going to set it up in that way, and then rotation, positive rotation, negative rotation about the x-axis is in that position. For our purposes, really that's what we're looking at. We have to make a decision. Is visually, is this going to screw me up if I leave it in that position? Probably not, but to be on the safe side, let's see, how would we rotate that? Let's go with, if I go to direct editing, I can move copy bodies. And rotation, if we pick an axis, well, I don't really have an axis. Linear, entity, coordinate system, or vertex. So my vertex would be the origin. If I had one, but if I need it, we'll come back. Rotation about the z-axis, 180 degrees. And since I'm not seeing a preview, that means I probably do need, let's see if we'll go origin. Oh, help to pick the body. There we go. And the circular pattern was the last one, and we're not copying. It updated. Didn't really want to do the move. Let's go 180 degrees. I saw it do it. Okay, so it got the origin as the rotation point, not copying. Okay. All right, so the last feature is the move copy body if I want to put it in that position. The other thing, probably preferable, is to leave this part alone and insert this into an assembly. So File, New, and go to my assembly inch. When I bring this this part in, well, it maintained the move copy body, so I'm going to drop it over here somewhere. We'll float it into position, and then let's see, let me get it out of position just for illustration purposes. All right, so it starts somewhere over there out of position, and so let's put that on the right plane, and we'll go coincident. Well, need to reverse the mate alignment. I'm going to flip the mate alignment. And then from there I can go top plane to top plane, coincident. And right plane to, should be, nope, front plane. Will be, nope, didn't hold down the control button. And coincident. All right, so that puts me into the orientation regardless of the part. The nice thing about the assemblies is this is now a machining document. The part can still technically be an engineering document, separate, pristine from going through anything that we would need to create for our geometry. All right, so a couple choices. Well, we haven't done anything out of the assemblies. Shouldn't see anything really different. Advantage of the assembly is that if I'm holding onto this with a 3-jaw chuck, I could find a model of a 3-jaw chuck and put this in place in the assembly and say this is my fixture. If I had a faceplate and I drilled holes through and I was going to put a little adapter plate or something to hold onto this face, I could model all of that geometry and have it for reference, have it available to assist me in the machining process. All right, so the top view, we have the counterbore, the chamfer. Let's see, front, and then we're going to be at the bottom, and then at the back. So those are the views that I'm interested in. So let's go ahead and save this, and I'll save it as the fourth again. So save. All right, so out of the assembly plane manager, the issue becomes: do we want to set up and see if I can scrunch that? Nope, guess not. Now let's see if we can. Oh, let's go pan. There we go. Do we want to set up a work coordinate on each of the corners? For simplicity, if I have machined this block out, or I've ordered this material to be 4 inches by 4 inches by 4 inches with a hub or not a hub, however we're going to hold on, attach, or otherwise secure this to the rotary table, I need to decide where each of those coordinate systems is going to be. All right, the advantage of an individual coordinate system is I can raise this face up and down in unique individual of this face. But on the other side is if my tolerances are open and I have done a reasonable job of locating for that position, it's going to be a lot easier to manage out of the center of the rotation, front face, center of the rotation. We're in the top plane, front, back, bottom, right, left. So let's stay with the top plane. What I haven't selected for, and we need to pick up, this defaulted again to the machine group. So one of the things we'd want to check pretty quick under the machines, the control. That wasn't the one I was looking for. There we go. The replace is what do we have for a 4th axis mill? All right, so generic has 3-axis, generic has 4th axis. The difference between these machine definitions and post is that whenever there is that rotation, whenever there is that initial positioning, this is going to have an A value associated to it, whereas it's a position in that space. So when you're picking these, watch out for the MMs for millimeter. Let's go ahead and open up for a 4th axis mill. Again, if we were running this consistently, we would have it picked as one of our selections in the machine pull down. Under the tool settings, we'll go with the program number, assign, warn, start is 1, increment is 1. I wonder if it'd bark at me if I put zeros. Strange things that I think about. So the bounding box, or we can select corners. Really, the stock is going to be from this corner to this corner, and that will get us our stock selection 2 and 2. That looks okay. And the starting plane at the top. Okay, so give us our position. I do want to check real quick on the plane manager. We're going to be, we said the top, the front, the bottom, and the back. All right, because we're still going to have to move to position, get into the orientation in relation to that tool direction. All right, so that's going to give me the same. So there's 2 sides to each of these planes. Front is going to be on this side of the plane, and the back would still be along the same plane, except the approach is opposite. All right, so visually, mentally, I just have to think in terms of this plane only has one positive direction. Anything that passes the front plane and goes the other side, we're into that negative territory. and we want the approach to be from the other side, that has to be a back. All right, so we're going to stay in the top at least initially because this is going to stay for our standard part. So well, let's go ahead and start putting some operations in. All right, so the mill toolpaths, let's go with a contour, tool 1. We'll pick up, and let's go with the initial face. And actually, I didn't want a contour, I wanted a pocket. No selection. Got contour on the brain, apparently. There we go, pocket. Grab our geometry, and keep in mind with the 0, 0 here, one of the tricks of this exercise is that we are machining in positive directions. So getting out of your comfort mindset of, oh, well, this is my 0 face, everything is a negative value. No, my clearance plane is a positive value, and then my machining directions, my machining depths are still positive values. So where we weren't really as concerned in 2D about the incremental just became a lot more important. All right, so chain direction, everything looks good there. We'll go ahead and accept. This will stay with the 4th. Pocket geometry, set up for the tool. 1/2-inch ball end mill, don't think so. We're going to select the library tool. Make sure we're on the filter. And 1/2-inch flat end mill. For our spindle speeds, because basically this is an unsupported load, we have enough mass here. So one of the considerations is this is hanging off the end of that rotary. We can inject anything that is injecting the harmonic vibration chatter into this part is going to be magnified because it isn't supported at its base or on 2 sides. It's basically all coming through that connection, all through that nose. All right, so RPM wise, we were running the 1/2-inch up around 9,000 feet per tooth. Yeah, let's keep it at 1,000. 36 is probably on the slow side, but again, we got to get it into the part making the cut, and then decide if that's good, bad, or indifferent. Plunge rate, we'll slow it down even a little bit more. We should be doing helical or ramps to get into the material. And for an aluminum cutting, 2 or 3 flute coated carbide end mill, 1,000 to 1,200 surface feet per minute is not outside of its capabilities. It is aggressive though. So, we're set up, and first article is going to be walk through it slow and make sure you know where it's going, what it's doing. Stock to leave on walls for the pocket. We'll go to 5,000s. Nothing to leave on the floor. Climb, conventional, tip, sharp, all of those can stay the same. Pocket type is standard. Not facing, not island, not remachining, not open. Roughing operation in this case, I would lean towards the spiral just because even though it's going to generate a lot of code, it's going to be a consistent load throughout the entire toolpath. Once it does that helical entry and gets to depth, the true spiral is going to have a constant engagement, radial engagement into the tool. So let's go true spiral. Step over percentage will probably drop down to 10%. And the intent would be to go from, once we get in, we see what the finish is like. The intent would be to go from like 36 inches a minute up to about 60 inches a minute if the finish will support it. All right, so step over distance of 50 thousandths, that's entirely doable. All right. 100 thousandths, we're increasing that load, we're increasing the vibration, we're increasing that harmonic. At its low end, we would go down to 10 thousandths, and then we would try to be running at 100 inches a minute. Right, so whatever we give in one direction, we have to take in the other to match. So I want to find a happy medium to where it's not crazy aggressive. The depth of cut, the radial engagements are kind of balancing each other out. Entry motion, the helix minimum radius, let's go down to 100 thousandths. Probably not going to need to get into that geometry that tight, but let's go ahead and get started with it. Half inch at the max. Always makes me nervous if all the entry attempts fail. Plunge. Don't ever like to see plunge. I mean, we're running at those aggressive speeds and feeds. Plunge is usually a bad thing. That's why the plunge feed rate got dropped back to 10 inches per minute, because even that is going to be a pretty good as it goes into the part. And then keep the entry feed rate at the same. Finishing, one pass. Let's turn the wear on so that we have access. Start the finish at the closest entity. We can, since we're not rotating, we'll keep the tool down. And shouldn't have to override, but we do have the overrides available. Lead in, lead out, little on the large side, so we'll pull those back to 100 thousandths, and well, let's go 50 and 100. And then I want to take everything on my entry and take it over to the exit. No depth cuts, breakthrough, none, linking parameters, incremental, 1/4 inch from the feed, 0.2 incremental, and then the top of the stock is shown as 2 inches, and that was taken from what we defined over in the stock at the machine group. And if I go to incremental, well, it's still showing 2 inches. That since we didn't pick anything, it's looking for a point, so we grab a vertex. That's an interesting number, 0.31. Can't say that I expected that one.
That is incremental, so is that above your depth?
Depth of the cut.
Bottom of the pocket.
Yeah, depth of the cut. Well, but the depth incremental should have, yeah. That makes sense. Yeah, it was 0.31 on the depth. Well, let's see what it does. Typically would like that number to be 0 and that number to be well, incremental minus, based on the selections, it should be, see if it changes. Oh, pretty much the same. So based on the contour incremental, I just repicked the contour. All right, and then being in the 4th axis, we do need to jump down to the planes. We're in the Mastercam top and top for each of those items. And big spiral in. And as large as that spiral is, it probably doesn't need to cut that much out of the center. Also with that spiral, even though we're cutting, basically it's back dragging the trailing edge of the end mill as it goes in with that big of a spiral and removing that much material. Oh, went back into the tool. Let's drop the maximum radius to 0.2. And then regenerate. So that's a little concerning that it starts off of the center. One more. And regenerate. Nope, still didn't center on the location. All right, so the issue, well, as long as it gets to that point and actually opened up the hole to that location, let's see, it would move to the center line. That would still be a pretty heavy initial cut. So I'm still not satisfied with that location for the roughing. Inside to outside's okay. I'm just double checking on my conditions here. And it didn't. It's not picking up the entry location. So let's see.
Is that the only lead in, lead out possibly?
Well, the lead in, lead out is associated directly to the finish operation. So since it's combining up the finish, there's not really a separation there. Okay, based on that, I was a lot happier with the 0.5 then. All right, so even though it's still making that that heavy loop, no, we'll check it out when we get over to the verify. All right, so that takes us into the next geometry. So under the plane manager, I'm going to the front. We're going to set everything into that that plane and accept. All right, so the front plane now shifts. XY is along, well, along my front plane. Z is pointed in the direction that I want it to, so my positive Z. Still not copying. We're going to, my tendency is to immediately go copy that, and that's still not a good idea. Pocket. We can go ahead and pick out our two geometries. Oh, and I didn't propagate. No, project to tool plane. Oh, I didn't propagate. Propagate along tangent edges. That looks a little better. And after doing the surfacing and seeing the white lines, but it's still not completing, I'm even a little nervous of those now. All right, I'll go ahead and make the selection. Looking at the tool, pulls over the same speeds and feeds. Pretty much the cut parameters, everything that we produced. True spiral in this case, yeah, it can stay a spiral. It's going to get a little interesting in the corners. Entry motion, finish. Should have enough room for the lead in, lead out. Linking parameters, well, probably did not get to that same location. So 0.25, 0 incremental to the selection, and under the planes, the work coordinate system went to the front, but the tool plane and the construction plane. So I'm not sure why those didn't come over. They were selected for.
Will those double arrows in between those two move those over?
Should. All right, well, we're going to have to see what the result is. Really, work coordinate system, tool plane, construction plane should all. Now the asterisks, though, and we have the correct direction. Front, WCS, and tool.
So the top of that says T plane is follows WCS?
Yeah.
And that box is unchecked now? Is that why they're different?
No, it was still checked.
No, right side. Where it says T plane follows WCS, or the little selection box outside that window?
Oh, T plane.
Is that the tool plane?
Yeah.
Is that why they have the asterisk?
Guess we're going to find out. I wasn't paying attention to that. That's why I have you guys ask the good questions. All right, so no, doesn't need to regenerate. It's still showing top. All right, so now we're gonna have to look into that combination. Feed in, out. All All right, so at the description level, top and what is it? And T-plane top, and it's still showing T-plane top as the asterisk. So yeah, we're either missing a checkbox or I'm missing something in the workflow. All right, no toolpaths. I'm going to stay with the pocket. Check the chain. Go ahead with the selection. And this time I did not select the plane, so we're going to do it inside of the operation. Cut parameters, everything, roughing. That one's kind of weird for the spiral, but we'll see what it looks like. I didn't pay too much attention on the triangular shapes. Finishing, linking parameters. Let's double check that top of stock, and it went up to 1/2 inch. And the planes, switch over to bottom, and then that one picks. And I still have the asterisk, but displayed relative to WCS. So that one pulled over. Does not lie in the construction plane. All right, so let's double check against the plane manager. Bottom, we'll set all those equal. That one rotated around on me, which sort of makes sense that as this is coming over, this is one that we ran into on the standalone too, is the direction of that that X value. See if it gives the same error. Nope. Yep. Nope. Okay, so the Z direction is correct. The XY, not so much.
Okay, so we're going to review the operations here real quick. Pocket on the top. We'll show those operations. All right, and it's settings that may have been adjusted, roughing, entry. We added a few, 1/2 inch or to get it more towards the center, reduced. Let's see the other pocket that on the entry motion. So let's go back and hide and show. Alright, so I made an adjustment that we could go in instead of because of the bow tie shape, that its entry motion would go from helix to ramp, and apparently that's not it. Showing which one, that must be the other pocket. There we go. Alright, so that helical entry is good. And the distance, didn't need the tool. And the entry motion, Z clearance, but reducing the minimum radius, maximum radius. Oh, those are still pretty much the same. Okay, so that picked up center. Let's take a look at this one. Entry motion, 0.25, 0.75 went to a ramp so that it would stay in the middle, and a clearance just to get it off of the edge. So that gets it pretty close to center, so when it starts the spiral outwards that it will not be taking those full depth passes. Alright, and then the slot milling, that one pretty much stayed the same. The pec drill, and refer you back to the standalone Mastercam for the explanation, but with the transforms, you have the pec drill. Let's go ahead and figure out which side that's on. Show. Okay. And we need to be in the axis that this Z is rotating around. So if we were on the top and in the top plane, or we say that this is the top plane, then rotating about Z would go this way. If we're in the left or the right, in this orientation, Z coming out this way, Z going in that way, then that would allow us to rotate around the axis. So when we set up this transform, we're going to rotate around the tool plane. Operation order or operation type don't matter with as much with the singles. We have 3 instances. First increment is 90 degrees, additional 90 degrees. The rotation set to the right side. All right, so to that axis, and then that sets up the drill paths in the correct order. Save it